In this video, we're going to go over how to use the quadratic formula to solve quadratic equations. Now, hopefully you've thought about and maybe watched a video about the differences between linear equations and quadratic equations. A lot of times when you see the quadratic formula, you'll see just this piece of it right here. But it's important to think about this piece right here, if ax squared plus bx plus c equals 0. That's a quadratic equation. It's not a linear equation. It has this x squared in it, which makes it a quadratic equation. So if you have an equation that's in this form, then you can find the value of x by plugging in the coefficients b, a, and c into this formula. Now you may look at this formula and think, where the heck did that come from? That looks like a crazy formula. I have another video about the proof of the quadratic formula so you can see where it comes from. The short answer is it comes from solving this equation with the a's, b's, and c's in it using completing the square. And if you want to see that, you can watch that video, and you may be required to watch that video if you're in my class and do the quadratic formula proof. But in this video, we're just going to look at using the quadratic formula to come up with answers. All right, so let's look at a couple examples here. I think that's the best way to dive in. Let's say we want to solve the equation 6x squared minus 5x minus 4 equals 0. Now notice we've got something in this form, ax squared plus bx plus c equals 0. Let's see if I can color code this a little bit. I don't know if I have an orange pen. Our a value is 6. All right, that's our a value. Our b value is negative 5, corresponding to this b, the coefficient on the x. And our c value is negative 4. C is negative 4. So all we have to do is plug these values into this equation. Now maybe some of you are thinking, I wonder if this factors. Maybe I could factor 6x squared plus minus 5x minus 4 equals 0. Well, maybe you can. Maybe it does solve by factoring. This is a little bit of a trickier one to factor, but if you want to pause the video and see if you can factor it, you could certainly try solving by factoring. Okay? We're going to look at an example in a minute that does not solve by factoring, but let's go ahead and plug this stuff into the quadratic formula and see what happens. All right, so I get x equals, then I have to do the opposite of b. Now this is important here. I love how this has got a black opposite sign and a red b. Our b value is negative 5. Okay, so when we plug this into the formula, we have to do the opposite sign, and then we have to do b. So we're going to do the, oh boy, here we go. Okay, so the opposite of b will be the opposite of negative 5. And for my first step here, I'll try to color code everything. Plus or minus the square root, all right, then I have b squared. So I have to do b. Make sure you put this in parentheses since b is negative 5 squared, because if you don't put this in parentheses in your calculator, it's not going to square the negative, and it's just going to tell you that the answer is negative 25, but it's not. Minus, and then this is always a 4. No matter what the equation is that you start with, you're always going to have 4 here. It doesn't have anything to do with this c being 4. This is always 4. And then you're going to multiply that by a. Oh, I don't want that color. Let's do this color. This is not light blue, but close enough. Multiply by a, which is 6. Then multiply by c, which is negative 4. All over, that's important, this fraction bar has to go all over that whole entire thing. 2, and that's always going to be a 2, times the a value, which for us is 6 in this particular problem. Okay, so these blue numbers, the 6, the red number, the negative 5, and the orange number, negative 4, will change depending on what equation that you're starting with. So now all we have to do is simplify this thing, and we'll do that using the order of operations. Okay, so I have the opposite of negative 5, that's positive 5. Bring down the plus or minus. Now you might be wondering, what the heck is this plus or minus symbol? Well, if you solved equations by factoring, you know that there's two answers in a quadratic formula, a quadratic equation. So the plus is going to give us one answer, and the minus is going to give us another answer, and we will separate those at the end. All right, so negative 5 squared is positive 25. Now be careful of your signs here, because you have a negative or a minus 4 times 6 times another negative 4. So this is going to end up being a positive. You have a negative times a negative. All right, let's see. 4 times 6 is 24 times 4, that's 96, right? Yeah, 24 times 4 is 96. All right, and then we're going to go all over 12. 6 times 2 is 12. Okay, next we're going to simplify what's under the radical, because that's like a grouping symbol. And what do we get? 96 plus 25 is 121. Next, we're going to simplify what's under the square root. Now, we got a little bit lucky here because this is a perfect square. The next example we're going to look at is not a perfect square, but the square root of 121 is exactly 11. Okay, now at this point, the next thing we would do to simplify would be to add or subtract in the numerator. So this is where we're going to divide this up into the two possible answers. One possible answer is 5 plus 11 divided by 12, and another possible answer is 5 minus 11 divided by 12. All right, so 5 plus 11 is 16 divided by 12. That's going to reduce. I'm running out of space here. We're going to work up. That's not my favorite thing to do. Reduce that down by a factor of 4 is going to be 4/3. And this one is, what is that? Negative 9 over 12? 5 minus 11? No, what am I? Negative 6. Higher mathematics. Negative 6 divided by 12, which is negative half. So our two solutions are x equal 4/3 and x equal negative 1/2. Now, if what's under this square root right here comes out to be a perfect square number like 11, guess what that means? That means the original problem was factorable. And like I said, they're not all factorable, and we'll do an example here that's not. But it does mean that this was factorable. Let's see if we can get it. 6 times negative 4 is negative 24. This is my little trick for factoring, how I like to do it. I do the a times the c. And then I think to myself, what multiplies to be negative 24 and adds to be the middle number, which is negative 5. So that would be a negative 8 and a positive 3. So that means I need my outside and my inside to be a negative 8 and a positive 3. So I'm going to do 3x and 2x. So this 3x, I need this to times to be 1 to give me the 3. And then the 8, I need, not 2, 4. Yep, 4. So 4 times 1 is 4. And that'll give me 8x there and 3x there. And I need this to be a negative 8x and a positive 3x. All right, that'll do it. So if I was solving by factoring, then I would set each factor equal to 0. I'd add 4 to both sides. Divide both sides by 3. There's your 4/3. And here I would subtract 1 from both sides and divide both sides by 2. And there's the negative half. And those are our answers. Now you might be thinking, well, shoot, if factoring it, why wouldn't I just why I gotta go through all this to do the quadratic formula? The reason is because not everything is factorable. And if it's not factorable, your only choice is to use the quadratic formula. But it's kind of cool to look at this example so you can see that they do come out the same. All right, you can use the quadratic formula on any quadratic equation. Factoring is limited. Now, before we leave this example and go to another example, I want to relate this to a quadratic equation in two variables. So this was in one variable, it just had x's. But if this was equal to y instead of being equal to 0, let's say we had the equation 6x squared minus 5x minus 4 equals y, and we thought about the graph of that. Now let's say we let y equal 0, and then we solve it, which is what we did right here. If we think about the graph, let's go look at the graph. Okay, here's y equals 6x squared minus 5x minus 4. If y is 0, what points does that give us on the graph? Right here, right? If y is 0, x is 1.3333. That's our 4/3. Here's our other point. If y is 0, x could be negative half. All right, so when we set y equal to 0 and we solve using the quadratic formula or factoring, we are getting the x-intercepts of the parabola, those two numbers, negative 1/2 and 4/3. All right, if we were to make a little table over here and we said, all right, what if y is 0? And we solve that, we'd get our two answers right here. So we know the point 4/3 0 is on the graph, and the point negative 1/2 0 is on the graph, and those are your x-intercepts. All right, let's look at another example here that is not going to factor. 4x squared equals 8x minus 1. Now, is this quadratic? Hopefully, yes. You could see, well, the thing that makes it quadratic is this x squared term. Is it in this form? Ax squared plus bx plus c equals 0. No, it's not, because it's not equal to 0. So that's the first thing we need to take care of. We need to move the 8x to the left side of the equation and move the positive 1 over there. So that's going to give us 4x squared minus 8x plus 1 equals 0. Okay, so I think it's always a good idea, especially as you're just learning how to do this, to write down your a, b, and c values. So our a value is the coefficient on the x squared, that's positive 4. Our b value is the coefficient on x, that's negative 8. And our c value is that constant term right there, which is 1. So now to solve the equation, we're going to take these values and we're going to plug them into the quadratic formula. Maybe you want to pause the video and plug that in and simplify and see how far you can get. That's always a good way to practice. Alright, so I'm going to go up here and do this. So x equals the opposite of b, and my b value is negative 8, so I have to do the opposite of negative 8, plus or minus the square root of b squared, and again b is negative, so I want to be careful to put that in parentheses, minus 4 times a, which is 4, times c, which is 1, all over 2 times a, which is 4. Alright, so now we're going to simplify. The opposite of negative 8 is positive 8. Negative 8 squared is positive 64. 4 times 4 times 1 is 16. 2 times 4 is 8. Simplify what's under the radical, and I get radical 48. Now, 48 is not a perfect square, okay? So that means this doesn't factor. You should have learned at this point how to simplify radicals. Now, here's part of the reason you learned how to do that, is because we need to simplify this radical. So let's go off to the side over here. Let's go over here. And remember how to simplify radical 48, square root of 48. We need to think of a perfect square that goes into 48. Not just numbers that go into 48, but perfect square numbers that go into 48. Like 4, 9, 16, 25, 36. Well, 4 does go into 48. And actually 16 goes into 48 as well. Let's pretend like you didn't realize 16 goes into 48. Let's say you just did 4, okay? So let's see, 4 times 12 is 48. And then you could split these up when you have a multiplication. So the square root of 4 is 2. Now we're left with square root 12. Does 12 have any perfect square factors? Yes, it does. 4 times 3. So we split this up again. That's a times. Square root of 4 is 2. I'm almost out of space here. 2 times 2 times square root 3. So that's going to give you 4 square root 3. So now I'm going to go back over here, and the square root of 48 is 4 square root 3. I have to simplify that. Now I can reduce this fraction because the two terms in the numerator and the denominator all have a factor of 4. I'm going to go ahead and show out each step of this. So you could factor a 4 out of the numerator. That's the greatest common factor, which would leave you 2 plus or minus square root 3 all over 8. And then reduce this 4 with this 8. All right, so 4 goes into 4 once, 4 goes into 8 twice. And that's going to leave you with 2 plus or minus radical 3 over 2. Now you could skip this greatest common factor step here if you wanted to just divide 8 by 4 to get 2, divide 4 by 4 to get 1, and divide 8 by 4 to get 2 to reduce this down. But you have to reduce every term by those factors. Now these are some weird answers, right? So my answers are x could equal 2 plus the square root of 3 over 2, or x could equal 2 minus the square root of 3 over 2. Now if you're asked for the exact answers, those are the answers. Sorry, it doesn't get any prettier than that. Those numbers you could actually plug back in for x and it would make this equation true. And now it's for a whole nother video simplifying that, but it does work and it's kind of a fun exercise to do. But you might be asked to round these to the nearest tenth or something. So let's try that. Let's try rounding these to the nearest tenth. Now when you punch this into your calculator, if you do it all in one series of keystrokes, make sure you put this in parentheses because you want to divide this whole thing by 2. Or you could do 2 plus square root 3 equals, get the answer, and then divide by 2. Alright, so why don't you punch those into your calculator and see what you get. Alright, so for the first one, you should get rounded to the nearest tenth, 1.9. That would round up to 1.9. Here, let me just do, mine came out to be 1.8660 something. So if I'm rounding to the nearest tenth, that's 1.9. And then the other one is to the nearest tenth, 0.1. Alright, because it came out to be 0.1339, so to the nearest tenth would be 0.1. So those would be the solutions to the nearest tenth. Now, let's relate this to the graph. Remember how we did that with the other one? Let's say we had this exact graph, or excuse me, this exact equation right here, except instead of a 0, there was a y here. And then we plugged 0 in for y. So if we plugged 0 in for y and then solved it, we get our answers of 1.9 approximately and 0.1. So that means the points 1.9 and 0.10 are the x-intercepts of this graph. Let's go look at the graph real quick, see how that looks. This is our old one. Let's get rid of that. Alright, so we got y equals 4x squared minus 8x plus 1. Okay, let's go look here. There's our first x-intercept, 0.134. Now we rounded it to 0.1, but remember it was 0.133. Let's look at the other one. 1.866, right? That's what we got over here. 1.866. Pretty cool, huh? So those are the x-intercepts of the graph. When you're solving a quadratic equation, you're getting 2 points on the entire graph. Now, let's say you wanted to let x be, let's go back over here. I don't have a lot of space here, but let's say you wanted to find another point on the graph. Let's do it up here. And you had 4x squared minus 8x plus 1 equals y. And let's say you wanted to figure out the x value when y was 4. All right, let's go look at the graph real quick. So when y is 4, that's right here. So there's two x values when y is 4. Looks like a little bit negative and then maybe 2 point something. So to solve that, you would let y equal 4. Now, to solve this equation, you'd have to subtract 4 from both sides. And you'd go 4x squared minus 8x, 1 minus 4 is negative 3, equals 0. Then from here, you'd have to do the whole quadratic formula again. All of this. And you'd end up with two x answers because of the plus or minus. And those answers would be these points right here. I can get as close as I can. Like negative 0.323 and 2.33. All right, those would be the answers you would get if you solved this quadratic equation. Okay, so that's how it relates to the graph. I cannot emphasize enough how important the quadratic formula is, and how important it is that you understand when to use it, how to simplify radicals, and how it relates to the graph of a quadratic equation in two variables. All right, well, I hope this helps.